interesting and useful operations that you might need. So today's topic is data visualization using Matplotlib and Cbone, and we've been building towards this slowly. So we've talked about the basics of Python. We've learned numerical computing with NumPy, analyzing tabular data with pandas, and now we're looking at data visualization. And you can run this code. We are currently running it on Binder, but you can also run this code on your computer. So the instructions for running it on your computer are given here. Okay, so let's get into it. Now, data visualization is the graphic representation of data. So what it involves is producing images that communicate relationships between the represented data to viewers. So the idea here is that a lot of the data that we deal with is in the form of numbers. It's in the form of tables or data frames or CSV files. And it's not really easy to look at a lot of numbers at once and understand something. But if you take the same numbers and then represent them using some kind of a picture or what is called a graph or a chart, then that leads to a better understanding of what the data represents and what the relationships between the different data points are. And in this lecture, what we are going to look at is some popular data visualization techniques, and we'll understand how to implement them using Python libraries, Matplotlib and Cbone. So to begin with, let's import the libraries. So we'll import matplotlib.pyplot. That is the module that is used for doing most of the basic plotting. So we'll import matplotlib.pyplot with an alias of PLT because that is the most common alias that is used in the data science domain. And then there is also a Cbone library which provides a Cbone module which we'll import as SNS. And this library is built on top of Matplotlib, and it provides many convenient methods that help you avoid writing a lot of code in basic Matplotlib. Okay. And apart from these two import statements, we also have this magic command Matplotlib Inline. What this does is this informs Jupyter that you want your graphs to show up as outputs below the cells where you've plotted them and not as pop-ups. So without this line, sometimes you may see that your graphs show up as pop-ups. Okay, so that's the setup. Now we've imported matplotlib.pyplot as PLT and Cbone as SNS. And to get started, we will study one of the simplest types of charts or graph data visualization techniques, and that is called line charts. And a line chart simply displays some information, especially a sequence of numbers as a series of data points or markers, and these data points are connected by straight lines. So let's see what that means. So here we have some data. Here we have a Python list called yield apples, and it contains 6 numbers. What this represents, it's an imaginary data set, but it could be a real one as well. So what this represents is the annual yield of apples in tons per hectare over 6 years in an imaginary country called Canto. So there's a country Canto where they grow apples, and we've simply measured the annual yield of apples in tons per hectare over the past 6 years. Okay, so ultimately those measurements turn out to be numbers like this. So now we have the yield of apples, and by looking at this, we might wonder what the trend is looking like. So we have a certain idea by looking at this that it seems like the yield is growing over time, but it's not very clear how fast or slow the growth is and whether this growth is likely to sustain. So immediately the simplest thing that we can do is we can plot it on a two-dimensional XY axis coordinate plane, and we can plot these points on the coordinate plane. So the simplest way to do that is to use a line chart which you can plot using plt.plot. So we say plt.plot and give it a sequence of numbers, and that sequence of numbers now gets plotted. So you can see that this was the number at the 0th index, 0.895. This was the number at the first index, 0.910, and 0.920, and so on. So already we can see that it looks like the yield of apples is growing with time, but it appears that the growth is slowing down. So it seems likely that over time this will flatten out around 0.95 unless we make some technological improvements or there is a significant change in climate or things like that. So that is the power of visualization. Just a simple graph. This is already giving you a lot of information. Now, one thing you may have noticed here is when we call plt.plot with yield apples, it draws the graph here, but it also gives an output. So this output is basically the result of the plot function. So the plot function returns whatever was called, and in this case it returns a matplotlib.lines.lines2D object. And we may not want to always look at this in the output because we are mainly concerned with the graph. So one thing that you can do is you can include a semicolon after your code. So if we call plt.plot with the semicolon, you can see here that now we do not have that output, the line 2D output, we simply see the graph being plotted. And in general, while using Matplotlib, you might want to just include a semicolon with the last statement so that you do not see an unintended output. Okay. So now we have a line plot and it's already telling us a lot, but let us enhance this plot step by step to make it more informative and beautiful. Okay. So the first thing that we are going to do is we are going to customize the x-axis of the plot. Now you may have noticed that here we know what the values or the yields of apples are, and this is plotted along the y-axis, but we do not know which years this data is for. And without that, this plot is not very informative. So the first thing that we can do is we can change the x-axis to show the actual years. So here now we have two sequences. We have years, which is 2010 to 2015, and then we have the yield of apples. And now we are passing to the plt.plot years. So this will form the labels on the x-axis, the text on the x-axis, and then the yield of apples. These will form the points on the y-axis. So in a sense, we are actually giving it now a list of points. So for 2010 on the x-axis, we want to point to 0.895. For 2011, we want to show 0.91 and so on. So we plot it now. And now you can see that you have the years 2010, 11, 12, 13 and 14 and the corresponding values. So that's great, but it would be nice, as if we share this chart with someone, it would be nice to include information about what these axes represent, and these are called labels for the axes. So we can add labels for the axes to show what each axis represents using the plt.x label and plt.y label functions. And now one interesting thing to note here is that we've already called plt.plot, and any other plt functions that we call within the same Jupyter Notebook cell are going to get applied to the same plot. Alright, so we can actually write these in any order and all of these will get applied to the same plot that comes out as the output of this cell. So we call plt.plot and that plots the two lines, and then we say plt.x label and set that to year, and then we say plt.y label and set that to yield in tons per hectare, and that gives us this result. So we have the year here and then we have the yield in tons per hectare. So now this plot is starting to get a little better. Now what would be interesting is that, okay, we can see that the yield for apples is growing, but we may want to know if this is happening for other crops as well, or is it just that the whole agriculture sector is growing, so this does not really say a lot about apples in particular. Alright, and so what we might do is we might want to plot multiple lines within the same graph. And to do that is really easy. So all you need to do is invoke the plt.plot function multiple times with different data within the same cell. So here let us construct some more synthetic data. So here we have data from 2000 to 2011 because in a range the last value does not get included. So we have 2000 to 2011. So there are 12 years, and then we have the data for apples and the data for oranges for 12 years. Now already you can see here there are about 25 numbers you are looking at here, and it's very hard for you to make an inference even if you spend a few minutes looking at all the numbers. And this is where a visualization is going to help. So now we're going to plot plt.plot years and then plt.plot years with apples and years with oranges. So the x-axis remains the same. This is not necessary, but in this case we just want to keep the x-axis the same. And then we set an X label and the Y label, and then we plot it. So there you go. So now you can see that we have two lines for apples and oranges, and it seems, since we already know that this was the graph for apples, it seems like the graph for oranges is going down. So based on this, you may form a hypothesis that it's probable that maybe the demand for oranges is falling or the demand for apples is growing. So maybe some of the land that was being used for apples is now being used to grow oranges or something like that. And once you have a hypothesis like that, then you can go back and investigate and find out if this is indeed the case. This is great, but just by looking at this graph, it's not quite clear which line represents what. So we already knew this was apples and that's how we could tell. but you can actually include what is called a legend. So you can simply say plt.legend, and into the legend you can give a list of labels for each of the lines. So the labels will get applied to each line, and then you have the title. This title is applied to the entire chart as a whole. So now you see here, you can see a title, crop yields in Canto at the top of the chart, and then you have the apples and oranges, and then you have the yield in tons per hectare and the year. Now, as we add more lines, sometimes it can get difficult to understand where the points exactly are. So for instance, if we want to know the data for 2005, we have to estimate it a little bit. So we can tell that 2005 is around here, and so the value is probably this one, and that is about 0.908 or something like that. It's not very clear sometimes, especially in a graph like this, which seems to be growing linearly, where the points exactly lie. And this is where you can actually add markers to the points. So to show markers for the data points, we can simply use the marker argument of plt.plot. And Matplotlib supports many different kinds of markers like circles, cross, square, diamonds, and so on. And you can actually see a full list of markers here. So if you visit this page, you can just search for Matplotlib markers. You can see what the value that you need to provide to the marker argument and the symbol it displays on the screen. Okay. So let's try out a couple of examples. Now we are going to plot the yield of apples, and we are going to use a circular marker for it. So apart from the line, there will be a circular marker, and then for the yield of oranges, we are going to use an X marker or a cross marker. So let's run this. So you can see now you have circular markers here, and then you have cross markers here, and they're also represented in the legend. So this is a little better, but you might want to style these lines and markers. Suppose you want to use these in a presentation, then you might want to include some of your brand colors and backgrounds and things like that. So to do the styling, to style the lines and the markers, plt.plot, the plot function, supports many arguments for styling them. So you can use the color or C argument to set the color of the line. And once again, there are many inbuilt colors that are supported within Matplotlib. So here you can just search for list of colors in Matplotlib. And you can see here that there are a lot of colors already supported. And if you want to use a color other than this, then you can use the RGB hex code of that specific color to set a custom color as well. So you can set the color and you can set the line style. So you can have a solid line or you can have a dashed line. Maybe you have one primary metric that you want to show using a solid line and the rest you want to make them dashed. You can do that. And then you can set the width of the line. And each line's width can be set separately. You can set the size of the markers, and you can modify some colors of the markers as well, like the edge color, which is the outline of the marker, the edge width, the width of the outline, and the face color, which is the color of the filling in the marker if it has a filling. And you can also change the opacity of that specific line plus markers. So check out the documentation of plt.plot to learn more about what you can do. And here we've just included a few examples. So for apples, we are going to use a square marker and the color is going to be blue, and it is going to be a solid line with a width of 2 and the marker size of 8, and then the marker edge and the marker color is going to be different as well. And then for oranges, we are going to use the red color and we are going to use a dashed line. So we use 2 hyphens to indicate a dashed line, and then the line width and the marker size, etc. will also be different. And we are also setting an opacity of 50%, so for the oranges. So once we run this, now we see that now we have the crop yields in Canto, but now you can see that the lines are a little bit wider and the lines have bigger markers, and then the orange one is a little less opaque. It has an opacity of 50%, whereas the blue line, which is apples, is solid. So this is how you can modify the lines and the markers. Now there's one shorthand here, because often the most common thing that you want to do is to specify the type of line, the type of marker, and the color of the two things. So there is a FMT argument that you can pass into plt.plot, and that can specify the line style. So the way you specify it, you specify the marker first, then you specify the line style, and then you specify the color, all within a single string. So for example, here what we're doing is we're saying years, apples, and then fmt is the third argument that goes into plt.plot. So you do not need to call it as a named argument. So you can just pass in the third argument. So here we're saying that it will have a square marker, it will have a solid line, and it will have a blue color. Whereas oranges, we're saying that they will have a dashed line, and it will have a circular marker, and it will have a red color. So you can use this shorthand from time to time when you're quickly drawing some graphs just to differentiate between different lines. And once again, you can see that we've still copied over the X label, Y label, title, and legend. What you can do is you can take all of this. If you have plots that you want to draw in a certain way, you can take all of these and put them into a function so that each time you pass in two lists of values, apples and oranges, all these styles are applied to them, right? So you can use all the nice things that Python offers, things like functions, modules, and so on, to organize your code and organize your graphs as well. Okay, now one exception here is that if in the format argument, if you do not specify a line type, so in this case we are plotting years and oranges, and here instead of specifying a solid or a dashed line, we have skipped it entirely. So then the line will not be drawn and only markers will be drawn. So you can see here that you can just see the markers and not the lines. And this is a useful thing to have as well. Sometimes you might want to have a line for a particular set of data and you want to show points for another. So you can do that too. Okay. Now, if you want to change the size of the figure, sometimes the figure might be too small and you might want to increase the height of it, or you might want to increase the width of it. For that, you can use the plt.figure function to change its size. So you simply say plt.figure and then you set fig size, and then you give a tuple. So you can experiment with this, what the tuple does. So let me just try out 2, 2, and then you put in a sample value and see what 2, 2 gives you, and then use that to maybe make some changes. Let's try 8 and 4. So yeah, that way you can change the size and the aspect ratio of the image. Now already we are starting to draw pretty good line graphs, but one interesting thing that we can do just to make our charts a little more beautiful is to use the Cbone library. So now we are going to use the Cbone library for plotting, but one of its use cases is also to just improve the look and the feel of the graphs that we draw using Matplotlib without doing anything additional. All you need to do is import Cbone. So we have imported Cbone as SNS and then use the set style function. So the Cbone contains a bunch of predefined styles within the library, and you can get the full list of predefined styles here at this link. So for instance, one of the predefined styles is white grid. So when we say sns.setStyle white grid, what happens is a certain set of styles get applied to all Matplotlib charts, and this includes some background, some font colors, some other configurations, and we'll see an example of that. And this gets applied globally. So now this style is going to be used for any plot that we make using Matplotlib or Cbone. So now we do plt.plot, we plot apples and oranges in the exact same way that we did before, and we set the X label, Y label, and legend. So we're not doing too much styling here. And you can see that you can already see there are some changes. So the font is slightly different, and there is now a grid. So the grid makes it slightly easier to see, okay, where the values lie. For instance, you can see that this point is 0.93 and then this is 0.94. So this point is probably around 0.934. You do not have to draw an imaginary line in your head from here to here. You can just follow the grid. So that's pretty useful. And one style I like, so this is the white grid style. One style I particularly is the dark grid style. So you can just call sns.setStyle dark grid. And now we have the exact same code that we had in this cell that we're going to run, but it's going to have a slightly different style. So here now you see that now we have a graph where it has a background. So the part of the graph has a background, and then it has a grid as well. And then the colors are slightly different too. If you had used the default colors, then those would be slightly different too. You can see here that these colors are slightly nicer than the default colors that you will get with Matplotlib. This is one of the benefits of using Cbone, that it automatically makes your charts a little more beautiful. Now the next thing that, and here's one more example of that. So you can see that we've only called setStyle once, and then every subsequent plot that we every subsequent plot that we do will automatically have that style. Okay. But if you want to, you can also edit the default styles within Matplotlib directly. So Matplotlib has, so you can import Matplotlib, and then there is something called RC params inside Matplotlib. In fact, you can just check it out. Let's say we just print it out here, matplotlib.rc params. You can see a whole set of values here. You can see there are probably hundreds of values, and you can change the font size, you can change the font family, you can change the background colors, you can change the default you can change the default ways, the default grid, whether you should show a grid or not, and a lot of other things like that. You can change the default marker style, you can change the default line style, and so on. And the way to do it is to simply set RC params. So here, for instance, I'm changing the font size, the default font size to 14, and I'm changing the default figure size to 9,5. So just making it slightly bigger, and then setting the figure.face color to, this is basically transparent. So here, let me just take this same graph. So you just keep this graph, this picture in mind, and let me just take the same graph and plot it here. And you can see now that this graph is bigger. So this is nicer when you want to present, or let's say do a video. So I'm doing a video with you, I can show you this, and it's a slightly bigger graph, easier to see. And sometimes you might want a small graph as well. Now, one quick note here is any graph, if you want to just download it, you can simply right click and click save image as in whatever browser that you're doing, that you're using, and you can just save the image to a file. With that, we complete our discussion of line charts. And let us just save and upload our notebook to our jovian.ml account. So we just call pip install jovian, and then we import the jovian library, and then we commit, and then we commit the notebook using jovian.commit. So you can change the project name here to whatever you like. And this will ask us for an API key, which we can get from our jovian.ml account. So here I'm going to my account and clicking copy API key, and then I'm pasting the API key here. And what this does is this captures the entire notebook and puts it online for me to share and continue working on. So even if the binder instance shuts down now, we have the notebook on our profile. And you can see here that it contains the charts that we have drawn. And if we want to continue our work, we can simply click run and click run on binder once again to continue. So moving forward, next we are going to look at a scatter plot. So a line plot is primarily used to represent a bunch of values in a sequence, whereas a scatter plot is used to visualize the relationship between two variables as points on a two-dimensional grid. Okay, so what does that mean? A good way to look at it is by looking at an example. And for the example, we are going to use a data set that is already included within the Cbone library, but you can also use any CSV file and import it using pandas. So here Cbone contains a utility function called load dataset, and into load dataset we can give one of the predefined datasets that are included with Cbone. So we have flower, and that returns a data frame in pandas. So this is our pandas data frame for flowers df, but you could just as easily have done pd.read CSV here and passed in a path to a CSV file, and that would have worked well too. So let's study this dataset. So it looks like this dataset contains 4 or 5 columns. So it is information about flowers. So these are some measurements made on a total of 150 flowers. So here we have 150 rows. So for 150 flowers in a garden, let's say, we've measured the sepal length, the sepal width. So sepal is a part of the flower, and then petal is another part of the flower. So then we've also measured the petal length and the petal width. And we've noted the species of the flower. So this is a typical data set that you might work with. Alright, and this is you can learn more about it. Here's a link to the Wikipedia page. It is called the iris flower dataset. And the first thing that I wonder here is, okay, it seems like there are a lot of values of sepal length, width, petal and width, but the species seem to be limited. So the first thing that we can check is what were the species here. So if we just check the flowersdf.species.unique, so it turns out that there are 3 species, Setosa, versicolor and virginica. Now, let's try to visualize. You can see a lot of numbers here. So there's a sepal length and a sepal width. Now you might wonder, is there a relationship between the sepal width and the sepal length? Like when the length increases, does the width increase, or vice versa, right? Or is there an opposite relationship where if the length is low, then the width is high? Currently, by looking at just these numbers, it's hard to tell. You may have some idea that, okay, for 4.9 you have the width is 3.0, but for 5.1 the width is 3.5. So there seems to be an increase, but the relationship seems to be different here. Like the width is higher for flower 2, but the length is higher for flower 1, right? So it's not very easy to tell the relationship, and we can't even look at and grasp all the numbers at once. That's where we might, to visualize the relationship, our first instinct might be to create a line chart using plt.plot. So we may call plt.plot, and remember that we need to pass in an x-axis, a bunch of values for the x-axis and a bunch of values for the y-axis, and then all those points will be plotted and connected with lines. So here we say flowers df.length and flowers df.sepal width. So this is a series, or the column, this is a column from the data frame, which is a series object, a pandas series. And that is similar to a list in the sense that it can be iterated over. So Matplotlib can automatically work with anything that looks like a list. So a NumPy array will do, a pandas series will do, and so on. So we plot it, and that leads to this plot, right? So this plot is not very pretty or very useful and why do we end up with a plot like this? Because there are 150 values, and all of those values are in this range of, like in a small range of 4.5 to 8, you have 150 values for the sepal length, and then similarly in the small range of 2 to 4.5, you have 150 values of sepal width, and there is no natural order to either of these values, right? These are all completely random measurements. Earlier what we had ears, so we know that the ears would increase, so at least one of them was ordered, but here there's no order. So in cases like this, especially you might, first time you might try something, you start with a plot like this, and see, and if you get a bad output like this, then maybe a line chart is not the best thing to draw here. And the next thing that you should try is to draw a scatter plot. Now let's see a scatter plot. It's going to be somewhat similar to this, but instead of the lines, you will just have points. So for scatter plot, we use the scatter plot function from Cbone. Now Matplotlib also allows you to draw scatter plots, but it is a little bit limited in its power. So the scatter plot function in Cbone is much nicer to use. So we just say sns.scatterplot, and then we say flowers df, so dot sepal length. So this is the x-axis, and flowers df dot sepal width. These are the points on the coordinates on the y-axis, the corresponding coordinates. All right, and then once we call it, this is what we get. So now all the 150 flowers, the points have been plotted. Like for instance, this represents a flower with the sepal width of length of 5.5 and a sepal width of something around 2.3. And you can see that the scatter plot has automatically picked up the names from the series and shown them here as axes, as labels for the axes. And this is one of the nice things with Cbone. It saves you a few lines of code every time by automatically doing the right thing. But we were concerned about the relationship between length and width, but there doesn't seem to be a clear relationship here. In fact, like the points seem to be all over the place. But if you notice carefully, you will notice about 2 or 3 clusters. So you can see this one cluster of points here. These are all together, and then there are some outliers. And then you can see another cluster of points around here. These are all together, and then you can see another cluster of points here. So there seem to be 3 clusters of points, and you might have a hypothesis here. Okay, there are 3 species of flowers, and now we can see about 3 clusters of points. And it makes sense that across different species of flowers, we may not really see a relationship, but maybe if we just study a single species separately, maybe we might be able to find a relationship. All right. So this is where you can use the hue argument to scatterplot. So here now we are specifying flowers df.sepal width, and then we are also specifying a hue. So what the hue says is that you pass it another column or another series which has the same length as these two. So for each flower we also know a species, and now for each distinct value of species, the corresponding points will get a different color. Okay, And then one other thing that we're doing is we are increasing the size of the points. So you can just make the size of the points larger, and you can try experimenting with a few values here. I tried it and I found 100 to be a good value. Okay, so now we have this graph. So now here we have the sepal length once again and the sepal width. But now the dots are slightly bigger because we have a bigger size, and they are of 3 different colors. So now we have setosa, which is blue. So all the setosa flowers are here, and as we had guessed, so they do form a cluster. And then versicolor are orange, and then virginica are green. And now you can also visually see there does seem to be a relationship here that in setosa flowers, the sepal length tends to be a little bit low, whereas the sepal width tends to be high compared to other flowers. And there is a general relationship, probably as the flower grows, both the sepal length and width grow proportionately. So there seems to be like a line that you can cut through. Obviously, there are more factors involved, so this is not a perfect relationship, but you can see that there's some kind of a rough linear correlation. Then similarly, you can observe a similar trend for versicolor, maybe not so much, but versicolor values are somewhere in between both the width and length. And then you have virginica. So virginica tends to have pretty long sepals, but the width seems to be pretty small. And virginica also seems to be more spread out, so it's not as concentrated or as close to a linear relationship as we have seen in the others. So then we might want to go back and learn more about virginica. Maybe there are multiple classes of virginica flowers, or maybe they behave differently for a certain region. So this can inspire research when you plot a graph in fashion like this. Okay. And now we have a great plot, but it is missing a few things. One, it would be nicer to make this figure a little bit bigger, so we can do that. And the way to do that is because Cbone builds on top of Matplotlib. So whenever you call a Cbone whenever you call an SNS.scatterplot or a function like that, along with it, you can also include some PLT functions within the same cell. So you can say plt.figure, and that will apply to the same chart that is being drawn by scatterplot. And then you can say plt.title, and that will apply to the same chart as well. So in this way, you can mix and match things from Matplotlib and Cbone. And this interoperability is sometimes really useful. So now we have a title, and now you see that because we had a more wide graph, the legend was moved to this corner, and that allows us to see some points here. Then we have the sepal width and the sepal length as well. So this is how you modify a plot drawn using Cbone. Now, one other thing I want to mention here is that Cbone has a great inbuilt support for pandas data frames. So instead of passing each column as a series, you can also simply pass column names and then use the data argument to pass the data frame as the source for the data. So for instance, you can say here we have sns.scatterplot, and here we can say that we simply want to use the sepal length column as the X and the sepal width column as the Y, and the hue should be the species column, and then pass in a single argument called data, where we pass in a data frame. And then Cbone will automatically pick these columns from the data frame for the respective axes. So you can see here we get back the same result. So that's it for scatter plots. Now, I hope you're getting a sense of when you might want to use a line plot and when you might want to use a scatter plot. And even if it's not very clear yet, the best thing to do is just to try it out. That's the best thing about Jupyter Notebooks and about Python, that you can just first draw scatter plot and then draw line plot and see if it looks good, if it serves your purpose. If not, draw scatter plot. Maybe that will help you. That will help you visualize the data better, and so on. The next plot that we're going to look at is called a histogram, and a histogram represents the distribution of data for a single column or for a single type of variable, essentially. So what do I mean by that? I think the best way to look at it once again is using an example. So once again, we load up the flowers data set, the flowers data frame, and let us just look at the sepal width this time. So let's not concern ourselves with other columns. So histograms are typically just the data for a specific column. Now you're looking at a bunch of values here, and it seems like there is so you might wonder, okay, what is the range of sepal width in terms of the smallest and the largest value? And one way to do that is just to do flowers df dot sepal, or you can just do flowers df dot describe. Remember the describe function on data frames. So if you call the describe function, then for each numeric column, it tells you a bunch of statistics. If we look at sepal width, it seems like the minimum value is 2 and the maximum value is 4.4. So we already know a little bit. And then the mean is 3.0. So that means 3.0 is the average, and then there is standard deviation of 0.43. And that's good that now we know more than we did earlier, but it is still not very clear where the values lie. If we had to count, okay, how many values lie between 2.5 to 3 and how many lie between 3 to 3.5, we might not that way, and then if we were to plot that somehow, then it would be easier to visualize the visualize the distribution of the values along this range. And that is where the histogram comes into picture. That within the range of values that a variable takes, so sepal width in this data set takes the values from 2.0 to 4.4. So within the range of the values it takes, how are the measurements, how are the data points distributed? So let's just see it now, and then we'll talk a little more about it. So here we are saying plt.hist, H-I-S-T, for histogram, and we simply pass in the sepal width column to it. And we've also set a title, distribution of sepal width. Okay. So now we have this graph. So let's just spend a couple of minutes understanding what this graph represents. So here as we saw earlier, the range of values is from 2 to 4.4. Now this entire range of values taken by sepal width is split into 10 parts here automatically. So that's the default setting, and we can change that. So it is split into 10 intervals, and you can probably guess that this would be around 2 to 2.2, and this would be 2.2 to 2.4, and this would be 2.4 to 2.6, and so on. And then what we do is we look through the column, we look through this data of sepal width, and then we count how many values lie in this range. So in this case, about 5 values lie in the range of 2 to 2.2, and so around 4 values. So we draw a bar which goes up to the height of 4. And then similarly, we count the number of measurements that lie within the range 2.2 to 2.4, and then we draw a bar which shows the number. So this number seems to be around 7, and so on. So now when you study this, it seems like somewhere around 3.0, so it seems like from 2.9 to 3.1, somewhere around that range, there are 36 measurements. So that is where a large number of measurements lie. And then it seems like there are more measurements on the larger side than on the smaller side. So from 3.2 to 3.3, let's say 3.4 or something like that, you have another 30 or so measurements. Okay. So already now we know how the values are distributed, the values of sepal width, the measurements, how they are distributed in the range that they take. Now these bin intervals are currently a little bit arbitrary. We may not want to check between 2 and 2.2. That's a little bit arbitrary. We may want to have a fixed number of bins, or we may want to decide what the intervals, the bins. So each of these intervals is called a bin. So interval is a mathematical term and bin is the statistical term used with histograms. They mean the same thing. What we can do is we can specify the number of bins. So if let's say instead of the 10 bins, we wanted to see just 5 bins. So here now we can split the entire range into just 5 bins. And now we can see that, okay, obviously now if the bins are larger, the interval is larger, then between 3 to 3.4, it seems like you have a total of close to 70 values. Or what we can also do is we can specify what should be the points at which bins should be created. And the way to do that is to give a list or an array as an input to the bins argument. So there's a bins argument. So here we are giving an input. Let's just see what this does. So we are, to the bins argument, we are passing np.arange. So let's see what that does. So np.arange 2, 5 and 0.25. What this says is create an array that starts at 2, goes up to 5, not including 5. So goes up to 5 and it takes steps of 0.25. So we have 2, 2.25, 2.5, 2.75 and so on. Okay, so now we can take this array and we can give that as a list to bins, and then the Matplotlib will automatically create an interval between each 2 consecutive numbers. So 2.5 to 2.25 to 2.5, 2.5 to 2.75, 2.75 to 3, and so on. So these are much nicer boundaries to have, I think, in this case, compared to what we had earlier. So you can see now we are going between 2.0 to 4.5, and then we have these nice intervals that line up with our measurements. You can also have bins of unequal sizes if you want to. So here we have simply set the bin measurements to starting from 1 going up to 3. So that's a bin of length 2. And then starting from 3 going up to 4. So that's a bin of length 1. And then a bin of length half. So there you go. Now we have 3 unequal bins. And obviously when the bins are unequal, the data points that lie in each bin, the number of data points will change. But you can still see that even though the 3.3 to 4 bin is a little bit smaller, half the size of the first bin, it still has twice as many values. So this is how you can play around with histograms. Just change the number of bins and the size of each bin. But I hope you get the idea that the basic idea here is it tells you how a single variable, like the sepal width, how its measurements are distributed along the full range of values that it takes. Okay. Now, similar to line charts, we can also draw multiple histograms on a single chart. And we can reduce the opacity of each histogram so that because there are bars here and these are opaque bars, if one of the histograms is going to be drawn on top of the other, and typically this is the order in which they are listed. So the first one that you list is drawn at the bottom, then the second command that you include is drawn on top of it, and so on. So some of the bars of the first histogram may get hidden by the second, and to avoid that, what you can do is you can simply set a lower opacity for each of the histograms. So what we are doing now is we are taking the same flowers data frame, but this time we are going to filter out just a specific data frame for each species of the flower. So here we are saying flowers data frame where the species is equal to setosa, and similarly we have versicolor, and similarly we have virginica. So you can check here that for setosa DF, you only have setosa flowers. And you can verify the same for versicolor and virginica. So you have 50 flowers in each, and you can check that. Now let us plot setosa and versicolor using 2 different histograms. And once again, you can set the color using the C argument, but by default, if you simply plot 2 of them, Matplotlib will automatically cycle through different colors. So let's plot them. And we are plotting them with an alpha or an opacity of 0.4. It might be helpful to add a legend here as well because we don't know which one is which here. So if I just do plt.legend, and here we can say setosa, that should be the first one drawn, and versicolor. Alright, so here we go. So now we have setosa and we have versicolor. So setosa is blue. So it seems like the setosa flowers, the sepal width seems to be on the higher side, mostly higher than 3.0. Whereas for versicolor, the sepal widths tend to be on the lower side, so mostly between 2.2 to 3. And that's already a lot more information than we had earlier. So this is one way to show multiple histograms. But what we can also do is we can stack histograms on top of one another. So we can, rather than showing this on top of, rather than when I top, like above. So here actually it is, both are overlapping, but what we can do is we can put this bar above the previous bar. And the way to do that, it is actually a little bit easier, is into plt.hist, instead of passing a single set of values, you can pass multiple arrays. So we can pass the setosa df sepal widths, and we can pass the versicolor df sepal widths and the virginica sepal widths as a list. And then we simply specify the same set of bins that we want. And then we say that we want to stack them. So we set stacked equals true. And once we do that, you can see here that the bars get stacked, right? So there are these many. So for setosa, we can see that in the range of 3 to 3.25, there are these many setosa flowers and these many versicolor and these many virginica. And these many virginica flowers. And now this histogram obviously is a lot more informative than before. So you can see the overall trend. But you can also see the trend for each species of flower. So you can see that setosa lie in this range, and then virginica in this range, and versicolor in this range. So let us save and commit our work before continuing. Okay, so now we've looked at line charts, scatter plots, and histograms. The next type of chart that we're going to look at is called the bar chart. And a bar chart is conceptually very similar to a line chart in that they show a sequence of values, except that what we do is we use a bar for each value. We show a bar for each value rather than we showing points connected by line. And let's just see that as an example. So let's maybe first draw a bar chart for this data. So here once again we have the data for apples and oranges, and then years. So first we might want to draw plt dot, let's say plt dot plot, and we say years and apples. Oops. Yeah, so here we have a line chart showing the yield of apples. So that goes from around, it seems like it goes from in the range, it goes from around 0.35 to 0.9 and then goes up and down. Now a better way, now this is great to study the trend, line charts are great for that, but they're not very useful for comparing individual values, right? So you can tell probably that this value and this value is a little bit higher than this value, but it's not visually, it's not very obvious. And that is where when you want to compare data across multiple years, then it might be better to plot a bar chart. So we can just say plt.bar. And the only difference here is instead of there being points and these points being connected by lines, you have a bar for each year. And then the height of the bar goes up to the data points value, which is the yield of apples. Say plt.bar, and here we have the yield of this is the yield of oranges. So let me just plot oranges here. Yeah, so this is the yield of oranges, and you can see that the same thing is represented here. Now, and you can see that now it's not that easy. It's maybe not as easy as a line chart to visualize the relationship on how the trend looks, but it's definitely easier to compare across. So if you want to say between 2003 and 2005 or between 2004 and 2001, it's very easy to look through and identify. And one trick here is that you can actually draw bar charts and line charts together. So let's take this plt.plot, put it here. Let's also add a marker here. So let's make it a red line. Let's make it a circular marker with a dashed line and a red color. And let's also take the bar chart here. And let's put the bar chart behind. So first we will plot the bar chart, then we will plot the lines, and let's set a title. Okay, so there you go. So now we have a graph which shows both the same data, yield of oranges, both as a bar chart and as a line chart. So now it's easier to study the trend, and now it's easy to compare multiple values as well. And you can choose based on what looks better for you for that particular data set. You can choose which one to use, or you can use both. And then like histograms, you can also stack bars on top of one another. So for instance, here we can plot the yield of apples, and then we are plotting the yield of oranges, but we do need to specify that we need to use a bottom argument for the second bar. So here we are specifying that the bottom for oranges is apples. So this tells that the bars for oranges should be drawn at particular heights. So here you go. So now you can see the trend for apples. So you can see how the yield of apples changes. You can see how the yield of oranges changes. And then you can see how the overall yield, let's say this is the yield of fruits. So what is the overall yield of fruits? How is that changing over time? Okay. So that's the bar plot. And this was a convenient case because here we already had a single value for each item on the x-axis. So for each year we already had the average yield, but that may not always be the case. Sometimes we may want to show not a single metric, but we want to show an average of many columns on a bar chart. And let me show you what I mean by that. And for that we are going to use another dataset that is included within Cbone called the tips dataset. So this dataset contains some information about customers visiting a restaurant over a weekend. So from Thursday to Sunday, a bunch of customers visit a restaurant, and for each customer we note down a bunch of information. So for each customer, the information that has been noted down is the total bill, the tip given by the customer on the bill, the sex of the customer, and whether the customer was a smoker, and what time or what day it was. So whether it was Thursday, Friday, Saturday or Sunday, what time of the day it was, whether it was lunch or dinner, and what was the size of the party. So how many people were there in that group along with the customer in total. Okay, so this is the tips data frame, and you can see here that one of the questions that you might want to ask is, what does the average bill look like on a particular, or on every weekday or every day? So how does the average bills between Thursday, Friday, Saturday and Sunday compare? And to do that, you might have to do like a group by operation. So actually let's try to do that maybe. So let's say we have tips df and you might do group by. Yeah, so you might do group by, and on group by you may group by day, and then from that group by you may select simply the total bill, and from that you might then do mean. So now you have, this is the average total bill for on the days of Thursday, Friday, Saturday and Sunday. Okay, and then you can draw bar plot here. So you can just say plt.bar, and here you can just pass in tips df dot, let's just call this bill average df. So now we want to provide an x-axis and a y-axis. Now unfortunately in the bill average df, the day has become the index, so there's no longer a day column. But what we can do is we can simply use the index column. The index column is called day, and then we can pass in the bill average df dot total bill. Okay, and now we have the total bill, average total bill compared across Thursday, Friday, Saturday and Sunday. But we had to go through two steps here. We had to first do this group by operation, and then we got the average and then we plotted it. But since this is such a common thing to want to know, that you may want to see that for, let's say, for days, but then you may want to see how does the average bill compare across men and women, how does the average bill compare across different let's say smokers and non-smokers and so on. And that will involve all of these calculations. And that is where we can use the Cbone library, which provides helper functions so that we don't have to do this calculation. So instead of doing that entire calculation yourself, what you can say is you can call SNS, so cbone.barplot. And the bar plot is the plot for drawing bar charts in Cbone. And you can specify, so here we have specified the data as the tips df data frame. And here we have now specified the day as the x-axis. So we now say that we want to group on the day and we want to average the total bill, right? So on the x-axis we have the day and on the y-axis we have the total bill. And Cbone will automatically calculate the average and now plot a graph. So now you can see Thursday, Friday, Saturday, Sunday. We see a very similar graph, similar to what we saw here. But this is done automatically for us. And another thing this includes here is this line. So this line tells you that what was the variation in the values. So I think it's called confidence interval if I'm not wrong. Basically what it tells you is that 50% of the values lie in this range from here to here. So you can see that there's a lot more variation on Friday in the bill, even though the bill is lower compared to Thursday. On the other hand, on Sunday the bill seems to be the highest and there seems to be a much lower variation. And then Cbone has also automatically added these labels here: Thursday, Friday, Saturday, Sunday, the day and the total bill. So in a lot of cases I find myself using sns.barplot rather than doing plt.bar, especially when there is some average to be computed. Okay. One thing that we can also do is, just like a scatter plot, we can specify a hue argument, and that can be a third argument. So let's specify hue as sex. So we know that here in this data set we have male and female. Let's specify hue argument apart from the day and total bill. And now you can see that for each day you have two bars. So you have one bar for male and one bar for female. So it seems like on average you can see that the bill for the female is lower than the bill for the male. And there also seems to be, if you look at Friday, there also seems to be more variation in the bill from males rather than the bills from females. And then you can look closer into the data set. Maybe you can go and investigate and figure out why this is the case. Why is the total bill lower for female? Is it? And similarly, you can specify, you can just say filter on smokers. Let's see if the average bill for smokers is lower or higher. Yeah. So if a person is a smoker, it seems like on average their bill is higher, but then there seems to be a lot of variation. So I'm not sure if we can make that assessment, if we can make that inference very confidently. But that seems to be true on average, except again on Friday seems to be an exception, right? So the correlation between total bill and smoker is not as high as the correlation between total bill and or the average total bill and sex. Now one thing that you can also do is you can make the bars horizontal simply by switching the axis. So you can go from day total bill to total bill day, and that will switch the axis and draw the bars horizontally. And sometimes these are slightly nicer to look at, and it's really up to you, and like on a case by case basis you decide what looks better for your use case and do that. A good point where you might want to make these horizontal bars is if, let's say, you had a lot of values here, right? So if you had a lot of values here on the x-axis, you may instead want to make them, let's say the x-axis was countries and not days of the week. So then you would need to show 200 countries, and that's very difficult to show. So rather, what you might want to do then is use a horizontal plot. So you can show a list of 200 countries here, and then the y-axis could represent, let's say, something like population. All right. So that's it about bar plots. And once again, let's save and commit our work before continuing. And the next kind of chart, so we are only looking at a few common charts here, the ones that are used most frequently. And in fact, if I have to tell you from my experience, around half of the plots that I tend to end up drawing turn out to be line plots, sometimes bar plots, and then those where the line plots do not make sense tend to be scatter plots. And histograms are useful when you are visualizing a specific variable, just a distribution of values. So histograms are pretty useful as well. And then there is this last one called heat map, which you will use from time to time. Not very often, but this is also one of the most common plots. So to understand what a heat map is, it's used to visualize a two-dimensional data like a matrix or a table using colors. Now that's probably not telling you a lot, but the best way to understand it is to look at an example. So what we're going to look at is we're going to use a dataset called flights. Once again, this is included within Cbone. So we say sns.load dataset flights. So here what we have is we have data for years, for a bunch of years. So starting from 1949 to 1960, and then for each month, starting from January to December for each year, we have the total count of passengers in thousands. So these are the count of passengers who visited a certain airport. So this is the footfall at the airport. Okay, and we don't know. I can't recall which airport this is, but let's assume it's an airport. So in January 1949, 112,000 passengers visited the airport. In February of 1949, 118 passengers visited the airport. 18,000 passengers, and so on. We have this data for 1949 to 1960. Now what we may want to know is, what does the trend look like? What does the trend of passengers coming to this airport look like? Is it increasing or is it decreasing? And we could do a line plot. So we could simply do plt.plot. So this we have, let's call this df. Let's simply do df.passengers. And it seems like there's an increasing trend, but you can see that things go up and down. And a nicer way to visualize this, in my opinion, would be to use a heat map. And for using a heat map, we could, first of all, we have to represent this data as a matrix. So here what we're going to do is we're going to use